Recording in progress.
Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. Okay, so we're going to talk about vector or cross product. Okay, in the previous video, I talked about dot product or scalar product. So in this video, we're going to talk about vector product. Okay, now, one of the things I want you to know is that it's very important as we keep on progressing through this series. It's important that you watch the previous video and make sure you've taken notes and you've practiced with it more questions from the textbook, and make sure you understand those concepts. And if you don't understand, please don't hesitate to send me an email and I'll get back to you as soon as I can. All right. So before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're still waiting for. Please do so that when I post new videos, you'll be the first person to know. So let's get straight into it. Now, when we talk about vector product or cross product, basically it's a binary operation on two vectors that is going to result in another vector. But if you remember, for scalar product, after we're done with the binary operation, it gave you a scalar value, all right? But here, when you're done with the operation, it's going to give you another vector product. So that means the resultant product vector is going to be perpendicular to both the initial vectors. So there's so many things about this, the proving and the rest of it. I won't talk about it here. I'm going to just state how to get the formulas. If it's a two-dimensional product vector, vector product, or a three-dimensional vector product. So I'm going to show you how to do it. Is that okay? All right. So let me just, because I know students will take notes from what I say. So I'm going to make a note of this so that it's you can write it in your notebook. So cross product is a binary operation on two vectors that result in another vector. Now, like I said, unlike the scalar product, it had a scalar quantity at the end. Okay, you have a normal value. So if you look at the previous video when we're solving, when we're done with scalar product, when we're done with dot product, we get a number. But in this case, when we are done, we're gonna get another vector. Is that okay? So the resultant, so this resultant product vector is going to be perpendicular to the both initial vector. Okay, so therefore we can now say when you have a product A, cross product, you represent it like this. B is going to give us a resultant R. Okay, so we already know where R is perpendicular to both A and B. So where R is perpendicular to both A and B, okay? All right, so let's do this now. I'm going to talk about something first, but before I say that, just a reminder, okay? So if we are having, because some students usually ask, Mr. Terry, how will I differentiate a dot product from a scalar product? So if we have something like A dot B, now this is referred to as a dot product, okay? We talked about this in the previous video, dot product, or you can call it scalar product. All right, so you can have this as scalar product. Now, but if you have it like this, so they're asking you to do a vector product or a cross product. So you need to look at the question and you have to be very, very sure. So if the question is given to you in this way, all right, so they want you to do a dot product, but if it's written like this, they want you to do a vector product when you're working with vectors, okay? Please don't forget that, it's very important. All right, so let's proceed to the next one. Now, how do you the formulas for each of this, okay? So let's talk about the formulas, all right? So the general formula. So there's a proof for this, but I'm not going to talk about the proof in this video. You can go to the textbook and have it, okay? But here I'm going to just focus on just how to remember the formula. Is that okay? Now, the first thing I'm going to do is if you have a two-dimensional, so remember we talked about two-dimensional vectors. So if it's a two-dimensional vector, how do you get the cross product, okay? So for instance, for two-dimensional, so if you have A is equal to a two-dimensional, you just have A1 and A2. Does that make sense? And B, you have B to be equal to B1 and B2, okay? So, and then you are told to find A times B, okay? So, and you are told to find A times B. Are you seeing it? So A times B now, you would need to now, how do you do it? So what I always advise students is that you have to now multiply. So A times B is going to be A1. So basically, you're having A1, A2 multiplying B1 and B2. Okay? So what you do, it's not difficult. You just need to listen carefully. All right? So what you do is this. So how I remember this is that you just have to do something similar to what we did in metrics where we're finding the determinant. So something similar to that. So the A multiplied by B is going to be equal to, you have the A1 multiplying the B2. So you're going to have A1 multiplying what? The B2 minus the what? A2 multiplying the what? B1. The minus, you're going to have A2 multiplying what? B1. And this is going to give you an answer. So it's going to give you an answer, maybe CK, all right? And this is how you write what? This is how you write, find the vector what? Product. Okay? So here, in this place, in this case here, the C will represent will be equal to the constant, and the K is going to represent the unit what? The unit vector. All right, and this is the first formula for a two-dimensional vector. All right, so it's going to be, you have A1 multiplying B2 minus A2 multiplying what? B1, and that will give you the answer for that. So you're going to get a unit vector. All right, a constant with a unit vector. All right, so that will give you that. Now, what is the formula now for when it's a three-dimensional vector? All right, so when it's a three-dimensional vector, how do you go about it? Okay, a three-dimensional vector, how do you go about it? So I'm going to go to the next one, three-dimensional. So you have a three-dimensional vector. So number 2. So now we have three-dimensional vector. Okay, so the first one we just talked about is a two-dimensional vector. Now we have a three-dimensional vector. Then how do you go about it? All right. So now, if we're having a three-dimensional vector, so we have A now. So instead of it to be A1, A2, it's going to be A1, A2 and A3. So I've talked about the vector notation. So I believe we all know this now. And for B, it's going to be B1, B2, and what? B3. Okay? Now, the question now will be, how do we now find the what? The cross product for this. All right, so usually, so we're now having A multiplied by what? B. So we're gonna have A1, A2, A3, all multiplied by B1, B2, and what? B3. Okay? Recording in progress. All right, so how do you do this? I always advise students to use this simple technique. It's the best way to do it. So what do you do? So this is now going to be equal to. So what I do, so to start, just take a straight line and just cancel out the first one you have here. So you're gonna have this 2 now. So you're gonna apply the same thing we did in a 2-dimension. So it's gonna be A2 times B3. So it's gonna be A2 times B3 minus A3 times what? B2. A3 times B2. Are you seeing it? Then you go back, you repeat the same thing. You cancel this out. Yep. Take another straight line and you cross out the second one. Okay. Then when you're done with that, you then multiply A1 and B3, and then you multiply A3 and B1. Are you seeing it? So it's going to become A1 times B3 minus A3 times B1. Okay? Then we're done with that. Then we're done with the second one now. Let's see, clean this one out. Okay. Now we now go to the third one. We carry a straight line and cancel the third one. Then we repeat the same thing we did. It's going to be A1 and B2. So it's going to be A1 times B2 minus, you take another one, A2 and what? B1. Minus A2 times what? B1. And that is how you find that. So you can clean this now. So we have this out, and that out. So then we can now easily say that if we're finding the cross product now between, for a 3-dimensional vector, we can now say that A times B will be equal to A2B3 minus A3B2. You have A1B3 minus A3B1. And we have A1B2 minus A2B1. And that is how you do that. All right. So this is for when you have a 3-dimensional. This is the formula to get a cross product. And the previous one was when you have a 2-dimensional. You use this one to solve that. All right. So what I'm gonna do, let's just go straight and solve some examples now so that we can just make sense of what we're doing. So what I'm going to do, I'm going to start with the 3-dimension. Then after that, I'm going to proceed to do the 2-dimension. I think that will be easy to solve. So let's do the hardest one. Then we'll end up with something very simple. So let's pick an example. All right. So we have number 1, we're told to then find the vector product. So some textbook we call it vector product, some we call it cross product. So it's still the same thing. So vector cross product, okay, of the vector below. So we have P to be equal to 3, 4, 5, and Q to be equal to, we have the Q to be 5, 3, and 1. Okay? So look at this. So let's solve this together. So we're looking for P times Q. All right, so we have our P here to be 3, 4, 5, multiplied by the Q, which is going to be 5, 3, and 1. Okay, so let's go. So what do? Same principle. Take a red pen or something. You just cancel out the first one. So you're going to have 4 times 1 minus, you're going to have 5 times what? 3. 4 times 1, 5 times 3. Then you're done with that. Then you cancel out the second row. Then you're going to have 3 and 1 minus, you cancel out the other one, 5 and 5. Are you seeing it? Then we're done with that. Then we'll now do the third row, cancel this out. Then you're going to have 3 times 3 minus 4 times 5. Okay? So then you can cancel that out now. So we have this out, and this out. So we then have this. We can now say this is going to be equal to now. So P times Q is going to be equal to 4 times 1 will give you 4, minus 5 times 3 will give you 15. 3 times 1 will give you 3, minus 5 times 5 will give you what? 25. 3 times 3 will give you 9, minus 4 times 5 will give you what? 20. So now when you solve this, 4 minus 15 will give you minus 11. 3 minus 25 will give you minus 22. 9 minus 20 will give you minus what? 11. And that will be the answer for this. So therefore, we can now say the dot product of P and Q in that question, the dot product of P times Q is equal to minus 11, minus 22, and minus 11. So you can see what we're talking about, that at the end of the day, you're going to have another vector when you're done with the dot product. Is that okay? So that's what you need to keep in mind. All right, let me pick one more example. Let's pick an example on using a 2-dimension this time. Okay, so let's see what we get. So number 2, we're told that we should find the vector product. So, or some textbook, we call it the cross product, okay, of the vector below. Okay, so we have C to be equal to 2 and 4, and D to be equal to 5 and 6. Okay, so the same principle we're going to apply, nothing different. So we're going to have C times D will be equal to, okay, 2, 4 multiplied by 5 and what? 6. And now this will be the same thing. So it's going to be 2 times 6 minus 4 times what? 5. And this is going to be equal to, we're going to have 12 minus 20. And that will give you what? Minus 8. All right, so that will give you minus 8, right? But remember, I told you that you're going to have a constant plus k, so because it's a unit vector. So if you remember when I said for this, for the 2-dimension, you're going to have c and k, okay? So you can see it here. It's a 2-dimension, so we're going to do that. So it's going to be minus 8 what? K, because it's a unit vector. So when we go back here, it's going to give us minus 8 what? K. Don't forget that part. So therefore, all right, C times D is equal to minus 8K. All right, or if you want to put it, you can put it like this, minus 8K. All right, so that is that for that. So the next video, I'm gonna talk about when we combine dot and vector products. So a particular question having both of them together, how do you go about it? So it's some questions you might have to do a dot product first and do a vector product, and how do you, something like that. So we're gonna talk about dot and vector product combined together. So it's very important before you proceed to the next video, make sure you've watched the previous videos, solve questions from the textbook, and be sure you understood them. Then then you can move on to the next. So by the end of this series, you should be very, very, very confident on how to solve vectors questions, okay? Or any question relating to vectors. All right, so I'm going to see you in the next video where we're going to talk about how do we solve questions with dot and vector product combined. All right? So I'll see you soon. I'll see you in the next video.